All right, today we're going to look at lesson 6.1 called the Polygon Angle Sum Theorems. And our objectives are to find the sum of the measures of the interior angles of a polygon, as well as find the sum of the measures of the exterior angles of a polygon. But before we do that, we need to do a little bit of review on triangles. So a couple of things that we want to review. One of them has to do with the interior angles of a triangle. So let's put a triangle up here. I'll do the best I can to draw a decent triangle. That's not very good, but what do all the angles of a triangle add to? So if I had angle 1, angle 2, and angle 3, then we know the measure of 1 plus the measure of 2 plus the measure of 3. They always add to 180 degrees. We're going to use that fact today. The other thing we're going to use is a measure of an exterior angle as it compares to an interior angle. So like angle 1 and angle 4 in this picture, what would the measure of angle 1 plus the measure of angle 4 be? Well, they're a linear pair, and we said way back in September that we're going to work with linear pairs all year in geometry. And here they are showing up again, that the measure of an interior angle plus the measure of an exterior angle, they will also add to 180 degrees because they're a linear pair. So we're going to use those two facts quite a bit as we move through 6.1 today. So let's take a look at the solve it activity, which starts chapter 6 or lesson 6.1. So it says to sketch a convex pentagon, hexagon, and heptagon. For each figure, draw all the diagonals you can from one vertex. And we're going to look at what a diagonal is. And we're going to make a conjecture or an educated guess about the relationship between the number of sides a polygon has and the number of triangles formed by those diagonals. So there's a pentagon and a hexagon, 6 sides, and a heptagon, 7 sides. So first question is, what is a diagonal of a polygon? It's a segment that connects two non-consecutive vertices. Okay, so in the pentagon, there were 2 diagonals, 1, 2. In a hexagon, there were 3, so we're connecting this vertex with the non-consecutive vertices. Now this one's already connected, it's one of the sides. So the red lines are the diagonals. A heptagon, there's 1, 2, 3, 4 diagonals. So let's keep going. So in a pentagon, there were 5 sides. How many triangles are made when we draw on the diagonals? 3. In a hexagon, it made 4 triangles. In a heptagon, it made 5 triangles. So what conjecture can we make? How many triangles are there compared to how many sides there are? So in a 5-sided figure, we had 3 triangles. In a 6-sided figure, we had 4 triangles. And in a 7-sided figure, we had 5 triangles. So what is your educated guess? Well, the number of triangles formed by the diagonals from one vertex is just 2 less than the number of sides of the polygon. So here's a question. Sorry about that glitch. If it were a 10-sided figure, a decagon, how many triangles would be formed? Well, it would be 2 less than the number of sides, or 8 triangles. And here's what's important. How many degrees do the 3 angles of a triangle add to? Well, they add to 180. So these angles add to 180, these angles add to 180, and these angles add to 180. And we're going to use that in the next theorem we're going to look at. So the first theorem we have is Theorem 6.1, the Polygon Angle Sum Theorem. And this is that the sum of the interior measures of the angles. So these are the angles on the inside of a polygon. If we add up all the inside angles, of an n-gon, and n is just a variable for the number of sides, is n minus 2 times 180. Where do we get the n minus 2? Well, that came from the solve it activity. If it was a 5-sided figure, it made 3 triangles. 3 triangles, each of them 180 degrees. If it was a 5-sided figure, it made 3 triangles. So let's do a 10-sided figure. It would make 8 triangles. Each triangle is 180, so 8 times 180 would be what all the angles add to on a 10-sided figure. We can look at an example of that here in problem 1.
In this problem, you will find the sum of the measures of the interior angles of a polygon. What is the sum of the interior angle measures of a heptagon? Use the polygon angle sum theorem.
So there's theorem 6.1. It says all the angles are going to add to n minus 2 times 180.
How many sides does a heptagon have? A heptagon has 7 sides. So substitute 7 for n.
So the 7 minus 2 is going to give us 5, which means a 7-sided figure, if we draw the diagonals in, has 5 triangles in it. Each triangle is 180.
Subtract inside the parentheses. And multiply. The sum of the interior angle measures of a heptagon is 900.
So what we've done so far is we've worked just with triangles. We know the sum of the interior angles of a triangle is always add to 180. Now we can expand that and look at any polygon. Okay, so let's go back to our pentagon problem. Let's say we have a pentagon and it's a 5-sided figure. Now this is not a regular pentagon. Remember what regular means. Regular means all sides and all angles are equal. That's not the case in this one. So if we have a pentagon, how many sides does it have? Well, a pentagon has 5 sides. So what would all of the angles add to if I took angle 1, 2, 3, 4, and 5 and added all those angles together? What's it going to sum to? Well, we use our formula n minus 2 times 180. So if it has 5 sides, we substitute that in. 5 minus 2 times 180, which would be 3 times 180. And 3 times 180 is 540 degrees. So in a 5-sided figure, all the angles will add to 540 degrees. Okay, now we're going to branch out and use the theorem a little differently. Here's another example of a problem you may see in your homework.
In this problem, you will use the polygon angle sum theorem. The housefly, Musca domestica, has eyes that consist of approximately 4,000 facets. Each facet is a regular hexagon. What is the measure of each interior angle in one hexagonal facet?
Now note the difference in this problem. It didn't ask for what is the sum of all the angles. It asked for what is the measure of each interior angle. And we'll still use theorem 6.1. We're going to use a corollary of theorem 6.1, and we'll bring that up in your notes here in a second. Let's finish the problem.
How does the word regular help you answer the question?
Now we mentioned that before. Regular means all sides and all angles are equal. They're all the same, and that's going to help us in this problem.
The word regular tells you that each angle has the same measure. Remember that you can use the corollary to the polygon angle sum theorem to find the angle measures of regular polygons. Use the corollary to the polygon angle sum theorem.
And this we're going to put up in our notes in just a second. What this says is that we're going to find what they all add to. That's the n minus 2 times 180. And then we're going to divide it by the number of sides. Because in this case, there would be 6 sides and 6 angles, and they're all the same. So they're all going to share whatever the total is.
A regular hexagon has 6 sides, so n equals 6. Substitute 6 for n. Simplify within the parentheses. Simplify.
So 4 times 180 is 720. All the angles, all the inside angles will add to 720, and we're going to divide it 6 ways.
The measure of each interior angle in one hexagonal facet is 120.
So each angle in this regular hexagon will be 120 degrees. And if we took 120 times 6, we end up with 720. So here's the formula we use. It's the corollary or an extension to the polygon angle sum theorem. In this case, instead of the sum of the measures of the interior angles, we're saying the measure of each interior angle. Each interior angle of a regular n-gon is the number of sides minus 2 times 180. This gives us a total, and we divide it by the number of sides or the number of angles that we have. Let's look at one more problem.
In this problem, you will use the polygon angle sum theorem. What is the measure of angle y in pentagon TODAY?
So what we're looking for is this missing angle, angle y right here. So if we knew their total, we could take the ones that we know and subtract it from the total to find out what's left over for y.
How does the diagram help you? You know the number of sides and 4 of the 5 angle measures. Use the polygon angle sum theorem for n equals 5 to find the sum of the measures of the interior angles of a pentagon. Substitute the values for the given measures of the angles. Then simplify each side of the equation. Subtract 470 from each side to solve for the measure of angle y. So the degree measure of angle y equals 70.
Okay, the last theorem in there sometimes is so easy that it causes us problems. Theorem 6.2 says that if we take the sum of all the exterior angles, one at each vertex, so we've got this angle 1 that's formed by this exterior angle, 2, we make an exterior angle at this vertex, 3 is an exterior angle, 4 is an exterior angle, 5 is an exterior angle. So for any polygon, the sum of the exterior angles is always 360. If it has 3 sides, it's 360. If it has 10 sides, the exterior angles all add to 360. If it has 200 sides, the exterior angles always add to 360. So Theorem 6.2 is saying if we add up all the exterior angles, they always add to 360. So we'll try a couple different problems dealing with exterior angles. The first thing says, let's find the measure of an exterior angle of, let's say, an octagon. So an octagon has 8 sides, and we want to find the measure of one of the exterior angles. Well, we know all of them are going to add to 360. Regardless of how many sides it has, the exterior angles add to 360. And if there are 8 of them, we're going to take 360 divided by 8. So 360 divided by 8 is 45 degrees. So each exterior angle will be 45 degrees. What is the measure of an interior angle if the exterior is 45? Well, from what we knew already, an interior angle plus an exterior angle, always add to 180. So to find the measure of an interior angle, we'll take 180 minus 45, which would be 135 degrees. So just based on the number of sides, we were able to find one of the exterior angles and one of the interior angles. Let's try another problem that deals with interior and exterior angles. Let's say the measure of an exterior angle is 72 degrees. That's an exterior angle. What is the measure of an interior angle? That'll be the first thing we're going to answer. And how many sides does it have? That'll be the second thing we'll answer. Well, if an interior angle and an exterior angle always add to 180, to find an interior angle, we're going to take 180 minus 72, or we get 108 degrees for the measure of an interior angle. How many sides does a figure have? Well, if they all add to 360, and each one of these exterior angles is 72 in a regular polygon, how many sides does it have? We take 360 divided by 72, and we get 5. It has 5 sides. So the exterior angle sum theorem we can use a lot. In fact, it gives us some shortcuts to doing problems. Okay, the last thing I need you to do to get credit for this video is to go to our homepage, the classroom homepage, and I want you to click on the Pearson Realize button. And that's going to bring up the Pearson Realize site. Now, I'm already logged in, but it'll bring up your login page, and you go to your login page and you'll select classes. And under the classes, you're going to see an assignment. Let me take a second, and I'm going to log out, and then I'm going to sign in, and we'll use AJ's. So when you sign in, you'll go to classes, and then on the classes, you're going to see a lesson 6.1 quiz. Select the 6.1 quiz, click on it again, and you can start your quiz. To get credit for the video, you're going to need to answer the 5 questions in the quiz. Once you've answered those 5 questions, I'll get notified, and regardless of how well you do on the quiz, you'll get points for taking the quiz. So make sure you do that to get your points for the video. All right, so that's lesson 6.1, the polygon angle sum theorems. We use the polygon angle sum theorems to find the measures of the interior angles of a polygon. We also use it to find each interior angle. And then we use the exterior angles theorem, where all the exterior angles always added to 360. We also use that to be able to find the measure of an interior angle as well as the number of sides. So a lot of information, a couple of different formulas you're going to need to know. So if you didn't take notes on the key concepts, make sure you go back and get those into your notes. Good luck.